All right, here we are, Unit 2, Topic 3, so 2.3, the structure of ionic solids. So solids pretty much are always solid. When you heat them up, certain ionic compounds will do certain things. Some just decompose because they can't actually exist in a liquid state. Some of them will melt, but you know, we don't like to talk about that too much. Ionic compounds form different solid crystalline structures, basically based on the charges of the atoms, how big the atoms are. There's a whole bunch of different arrangements, and that's all this learning target is about. So I think there's only one piece of essential knowledge. The cations and anions in an ionic crystal are arranged in a systematic periodic 3D array that maximizes the attractive forces among the cations and anions while minimizing the repulsive forces. And you don't need to know each different type. Here's a pile of oranges. So if you look at these oranges, you can see that they're not stacked on top of each other. They kind of fit in nicely. And this is called hexagonal close packing. So if you just look at these down here, kind of looks hexagonal like a honeycomb. So this one, there's 1, 2, 3, 4 rounded, and then probably a fifth and a sixth there. So round objects, spheres and such, will naturally pack themselves together in a hexagonal shape, just because that's the most efficient way to pack spheres. So a lot of crystals will do that. So this is cesium chloride, and this forms a corner cubic structure. And then this is a face-centered cubic structure. And then this is another face-centered cubic structure, but on the different face. So these are different ions that basically form different structures. Again, you don't have to have the structure memorized. And then here's two different types of hexagonal packing. This one, we have a set of 6, and then a set of 3, and then another set of 6. And then this one, the hexagonal basically is kind of diagonally. So these are actually different even though they're both hexagonal. One of these will have a hole, like in between the spheres here, that you could actually drop something through. And one of these, it's blocked by a sphere. Forget which is which. I think this one will have the hole. It doesn't matter. But with the 3D models, like the actual big styrofoam ones, you can actually drop a pencil through one of them and not the other. So just know that we have different, basically, crystalline structures. If you've ever seen crystals grow, there's a whole bunch of different shapes of crystal, and that's dependent on the attractive and repulsive forces within the atoms. So depending on the nucleus, depending on the charge of the atom, depending on the valence electron arrangement, you're going to get a whole bunch of different crystalline structures. There are thousands of them. There are several common ones that occur a lot, but basically, there's virtually an unlimited amount, and that's it for that learning target. So real fun.